I wanted to talk really about some customer experience I've had with Cosmos DB. I'm going to show you as well how we can get started with it and what it really means for business intelligence professionals to use Cosmos with Power BI. So I'm coming at it more from the business intelligence angle. Now, just before we get stuck in, I'll tell you something that I thought was a funny story about Cosmos. I love Cosmos. I think it's great to use. I think it's very powerful. The reason I fell into Cosmos was really because one of my customers came to me and they said, Jennifer, we've got a problem with SQL Server 2005. And I thought, well, actually, the problem is SQL Server 2005. You shouldn't really have that in your technical estate in the 21st century, in this year. So I said, why have you got 2005? So off they went and they came back and they said, because we've got an application that runs in 2005 SQL Server. And I said, well, what possible application could require SQL Server 2005? And then he said, it's actually written in VB6. And at which point I thought, I just want to work with software that's written in this decade at this point. I'm not working with VB6. I'm absolutely not working with SQL Server 2005. So I went back and said, no, you need to re-architect that whole solution. Basically take your fingers off the keyboard and don't touch it. You get problems with it and we're not fixing that. It needs rewritten. So the developers I was working with, who are way smarter than me, we hit on the idea of using Azure Cosmos. The reason we started to use it was because it's very, very forgiving for developers and they don't have to worry so much about the data structures underneath. They just feel it works for them, it gives them big, high performance and gives them global availability, which is what I needed. This was a global customer running this really old software. So when they started using Azure Cosmos, it was like they'd seen a colour television for the first time ever. They thought, wow, this is incredible. And I thought, this is a cloud. So they really went from an old legacy application on deprecated software to using Cosmos. And it was a big move for them, but I think it really, really worked and they're very, very happy with it. So that's how I came into Cosmos. It was a great solution for legacy software in an organization that was very developer heavy, but really didn't have much in the way of data experts, which is why I was there, masquerading as one. So how did we actually get to the point where organizations decided they needed to use big data sources? Now, personally, I'm not a huge fan of the phrase big data. I feel it focuses on the size and forgets about the original problem and also forgets about the fact that big data can really be data that's shaped differently, that's coming at us very fast. We've obviously got a 3Vs model, but that's really about the velocity, the speed of the data, and the shape of the data, not just the volume. Big data seems to focus on the volume. So why did we get into a situation of using NoSQL and big data? Basically because the world needed it. For example, in the police force in the UK, we're using Oracle. So obviously at some point you start to think we can't keep using relational databases. We need something to store more and more data. And we can see that with lots of other examples. For example, Google and Yahoo created solutions that would help them to really work with lots and lots of data. So it really meant a new paradigm was required, and that really meant that we had the opportunity to do something really, really interesting with our data. So now you might well have heard the phrase that says you can't have things fast, good or cheap, you pick two. So you can have either good and cheap, or fast and cheap but not very good, or you can have things that are good but not very fast. So how does that actually work? Well, the CAP theorem is a bit the same. Basically you get three choices and you can pick two, and that's where Cosmos starts to come in. What we have here, we have got the CAP theorem where you can have consistency, partition tolerance or availability. It's a theoretical concept in computing science. It's called the CAP theorem. It's also named sometimes the Brewer's theorem after the computer science who invented it. And it really means that it's impossible for a distributed data store to simultaneously have all of these three things. So consistency really means every read receives the most recent write or an error. Availability means that every request receives a response, which doesn't result in an error. But that's without the guarantee that it contains the most recent write. And finally, partition tolerance. And that really means that the system, the distributed data store, continues to operate despite an arbitrary number of messages being dropped or potentially delayed by the network between nodes. So this really implies pick any two. And in this diagram, what we've got here is we've got some of the names that you'll have heard of before and where they tend to sit in this explanation. So we start to move into big data stores. So what does this actually mean then? So we have got ACID in terms of databases. If you're a database expert, you will know already about this. And for people that are new to this, I'll just give a very, very brief explanation. So when you apply the CAP theorem, what that really means is you've got the opportunity to think about databases in terms of ACID atomicity, all or nothing. We also think about consistency, which really means that any transaction should result in valid tables. Nothing should be invalid. We've also got the concept of isolation. And isolation means that transactions can be executed concurrently, which really means that you can read and write to multiple tables at the same time. This means that the concurrent execution of transactions leaves the database in the same state that it would have been if the transactions were executed sequentially. So that's really what isolation means. So it's the main goal of concurrency control, and it really depends on the method used and how it's achieved. The final one is durability, and that really means that the database will survive system failures. And that really is a guarantee that once the transaction has been sent or committed, it will remain committed even in the case of a system failure. This means that transactions that are completed are recorded in non-volatile memory. So basically they are written. So that's what ACID is, and that's what we normally think about when we think about databases, when we think about the relational world. So the NoSQL movement has applied the CAP theorem as an argument against traditional ACID systems. ACID systems prioritise consistency and partition tolerance at the cost of potentially quite low availability. So that's how we end up with base systems. Base systems mean they're basically available, where the system seems to work all of the time. Then we get the soft state where it doesn't have to be consistent all of the time, and eventually consistent, which means eventually everything will catch up and we'll get to the same state as it was before. So base really is the opposite end of ACID, and CAP theorem is really a continuum along which base and ACID are in opposite ends. So as we summarise with CAP, pick two, but you can't do all three. Base that we have here really focuses on partition tolerance and availability, and it puts consistency, puts that in the back burner. So what we do notice is it's not just as simple as saying, right, I'm going to choose this particular technology or that particular technology. We have to think about the structure of the data. So here I've got some examples in how you might actually consider your data. So data, you could see it as structured data. Now you're accustomed to that. We see it in Excel. We have rows and columns of tables of data. Then we get semi-structured data. We have some JSON formula data, which we will have a look at later on in this session. And we've got unstructured data. Now unstructured data can consist of things like weather data, for example. It could also be video data, things which don't follow a common pattern. So the one that we are going to focus on for the purposes of this particular demo is semi-structured data. We will look at JSON format, and I'll show you what that is. But before we do that, let's demystify what some of these sources and these data types actually mean. So relational database, we already know about that if you know about databases. Tables of data in rows and column format, where the columns have got usually different data types from each other. You might have text, number, integers all together. OLAP, which I personally really love, which is where we have online processing of lots of metrics of data. We use this a lot in business intelligence, where we have lots of aggregations and the data gets summarised and presented in reports and dashboards. So here we've got key value data. So key value data, as you can see here, you have a particular key which acts like a locker and gives you the value back again. So then we've got Cassandra database, column store is where you've got a database object that contains columns of related data. These can be known as a tuple or a tuple. I'm going to say tuple, so Feel free to flame me at the usual address if I don't say it properly. So the database object really works where the key is mapped to a value, and that value is actually a set of columns. So you could see it as a column family as a table, and each key value pair being a row, and each column has actually got a table inside it, which consists of a column name, a value, and a timestamp usually as well. If that was a relational database, you'd have a column for each one of those entities, but actually because it's a column family, it's like you have another table hidden inside that particular row at that column point. So an example of that would be Cassandra databases. So then we've got the graph database as well. If you like Twitter, you'll be familiar with graph databases. It's that sort of a networking format. Graph databases are really interesting. It's a database basically that uses graph structures for semantic queries, and it uses nodes and edges and properties to represent, store and discover data. Microsoft also offer a graph database functionality. You might be interested to go and have a quick look at that. In Cosmos, you actually use Apache Tinkerpop and Gremlin to give you that functionality. So then we've got document databases. Document is more towards JSON, where each entity is actually stored as a document. So they are quite nice to read. They tend to be quite readable. So we'll have a look at one of those. A document database is a type of non-relational database that's designed to store semi-structured data as documents. Now the reason I pull out these types of data sources is because Azure Cosmos DB gives you the opportunity to store these different types of sources in Microsoft Azure. So that's why we've focused on these ones specifically. The one that we will look at in this example is the document data store. So we've got a relational store, which we've already covered. I'll flash through these. The key value store is where the key is used to access data, and you could look at it as being like a locker. The key is used to access blobs of data. Those could be videos or images, and a key uniquely identifies each record. So here we've got some difference between the relational data store in the left-hand side, where queries return a set, and the key value store model, where the queries return a single item. So with lots of different examples where key value stores could be quite useful. They're very, very simple to retrieve data from. So here we've got the graph store, where data is stored in nodes. These nodes have properties, and they're connected by the strength of connections between the nodes. So here's a representation of what a document could be like conceptually. Data is stored in nested hierarchies, and the logical data remains stored together. So that's how those work. I'll show you a quick example of those. We've got some data in JSON format. The way that I envisage it in my brain is I see data as being almost like a tree where we distinguish structured, semi-structured and unstructured data. Now my mind is probably a dark place, but this is how I see it. I try and split it up in my mind of how the data sits in terms of how I can split it up and compare it against each other. So on the left-hand side, for example, I've got structured data, which I've then split into read-write and read-mostly, and then just some examples of how those data sources might actually appear. So back to JSON documents. So JSON actually is quite a well-known format for storing data. The reason people choose it is because it's actually a really good way of storing data flexibly in a structured format. And there's a lot of different databases that support JSON, and you might be familiar with some of these. Some could include MongoDB, for example. Couchbase is the same. It also stores data in JSON format. SQL Server as well in 2016 started to introduce that functionality. Apache CouchDB is also a document-oriented open source database management system that uses JSON natively. We've got Azure Cosmos DB, obviously, we're going to look at that one. Another one is also MarkLogic as well. React is another example. So there's quite a few different examples of databases that will use the JSON format. So JSON, just before it starts, actually stands for JavaScript Object Notation. And then what's nice about it is it's an open, human-readable standard that facilitates data interchange. And people may well be familiar with XML, which is another format for changing data across the modern web. So JSON supports lots of different data types you'd expect it to, such as integers, strings and Boolean values. It can also hold arrays, and it can also hold hashes as well. So lots of different things that it can actually store I've got some different geographical data to show you, so we'll have a look at that. So Cosmos itself can actually connect to different data stores further down the line as well. So you could use it with SSIS, you could use it with Power BI, and that's what I'm going to show you. We could use it with Tableau as well, for the Tableau fans there. And who doesn't love Excel? Excel is one of the best pieces of software on the planet. I'm sure that a lot of businesses are just running on Excel. Great software. We can also use that with Cosmos too. So here's what a JSON document actually looks like. So we've got some examples here. On the left-hand side, we've got volcano name, and you can almost see that as if it was the heading for a column. And we've got the volcano name, which is the mountain is called Rainier. This data here is just a sample of data, a sample JSON file, which is storing names of mountains and volcanoes around the world. So they've got the Rainier example here. You can see the country column, the property is United States, and then we've got down here the type of volcano, and that's stratovolcano, and the status, and the last known eruption. So last known eruption and when that actually took place. So what we can do is retrieve the volcano data, which I'll show you how we get the data into Cosmos, and then we can visualize that data in a Power BI report. So I'll sketch some outline before we dive in and do that. So what we can use is things like Power BI, and there's an Azure Cosmos DB connector. I should say the connector is still beta, so it's always a bit risky showing something that's in beta, but I'd like to show you how it's done, so we'll have a look at that. We might look at some DAX as well. So here's a sequence of events if we're looking at it from the Power BI angle. But before we do that, I'd like to have a quick look in Azure DB itself. So I'm just going to end that show there, and we will have a look in the portal. So what we've got here is the ability to look inside the Azure portal. I hope that that's nice and clear. I've just got Zoom It because I'm a huge fan of Zoom It. So I've just changed my portal so it's quite bright and white. I've got Microsoft Azure portal here, which we can get from the Azure portal, the URL there. And what I've done here, and amongst all my resources, is I've got an Azure Cosmos DB account. So what I'll do is I can show you how we set one up. So to do that, I'm going to create a resource, and then I'm going to type in Cosmos. I do this when I'm setting up a new resource because I can never remember where everything is. So I'm going to, when you start it up, it's obviously giving you a bit of the information about what Azure Cosmos actually does, so you can have a quick read at that. But the main thing to take away is that Azure Cosmos is globally distributed. That's why my customer got really excited and moved their legacy application, because they are a global organization and they were really concerned about how do we get this data across the globe to all of our offices that are everywhere. So it's obviously very fast, and there's a lot of guarantees about that, and then good service level agreements as well. So that's some reasons to use it. So it says here it's schema agnostic. So in this, earlier in this session, it explains different types of data stores that you could get, key value, for example, and we talked about graph database. We also talked about document store. So that's the fun thing about Azure Cosmos, is you can actually use different schemas to represent the data. So what we're going to do first is going to do create, and then that will ask us a few questions. So the first thing it wants to know, as you might expect, is which Azure subscription are we going to use? And then it wants to know which resource group we are going to use. So I've got a resource group already set up, which I'm going to call RG Demos. So I'm going to give it an account name, and I'm going to fill in that information just here. So because this is the Pass Hybrid chapter, Pass Hybrid virtual group. Now at this point I've actually got some different ways of trying to choose which schema I'd like to have. So here we've got the Azure Cosmos DB from MongoDB. So we talked a little bit about Mongo earlier, and that can be, examples of that could be the document storage DB structure that we looked at earlier. Then we've got Cassandra, So Cassandra, as we said earlier, is more column family, column store. Azure Tables is an interesting one. I've used that for one customer, and they basically take financial data overnight, and Azure Tables is a very good way of structuring that data. And then you've got Gremlin, and Gremlin is more your graph database. So you can see here already that we have got many different schemas to choose from, and our personal favourite, SQL, because we can't forget that. So for this particular example, I'm actually going to choose SQL, and then I've got the location. Now, you'll have worked out by my accent that I'm not located in Australia at all, so I'm just going to put UK South in here. Now, I've got some other options as well. I've got geo redundancy, and I could enable that, and multi-region rights. Now, this is just a demo, so I'm not going to enable those things. But then I can start to create the network as well. So I could create a new virtual network here. So I'm just going to call it Pass Hybrid VN for a virtual network. And then I've got the address here, and then I've got the default subnet, and I'll leave the default subnet address range in there as well. You can see there that the notation for the address range, that's all it's asking you there. So allow access from the Azure portal, we're going to allow that. Allow access from my IP address, I'm going to allow that as well. So that means we are allowing both of those. So that means I'm going to review and create. It's going to go off and think about it. So it's validated it. It's a tick in the box. If I wanted in Azure, I could use a template to automate the construction of the Azure Cosmos DB for different occasions, but I'm not going to do that here. Instead, I'm just going to click Create. Now you can see over at the right-hand side that the deployment to my resource is happening really quickly, and it won't take very long. You can see here in the resources I've got here, so we can see the deployments that I've got the virtual network here, that's created in the Pass Hybrid database account is set here as well. So we can see here how fast it is to set up. So that's the virtual network all done, and then we're moving on to the database account's been set up too. So what I'm going to do in the meantime, I'm going to leave that to run for a minute, so it won't take very long. And in the meantime, I'll go back, say home there. I've got my Azure Cosmos DB account just here. And here's one I set up earlier actually, which I called Jen Stirrup because I have no imagination and just use my name. So that other one is still generating at the moment. But what we can see here is in this one I created earlier, you can see the regions where Cosmos is actually set up. So it gives us the idea of the regions where it's available. So like other Azure artifacts, it needs to sit in a resource group somewhere, it needs a subscription, and then I've got read-write locations in case you wanted to separate those out. Now, how do I get data up into Azure Cosmos? Well, you can do all sorts of things actually. One way you could do it is to use the Data Explorer functionality. There is an older functionality to do it, which is called Document Explorer, but that was more relevant to Documents DB, so that's been deprecated. And what we can see instead is we can use Document Explorer. Before we jump into that, we'll have a quick overview of this one. So we've got the activity log here, tells us exactly what's has been happening. I can go and visualize that, it's a good way of monitoring. So you can see here I've listed the keys, and it just gives you some information along with the subscription and who did what. So obviously me. And then if I want, I could tag this. Now I suggest, although I've not done it here, I suggest and recommend that you do tagging of Azure artifacts when you start to think about using Azure billing and tying things back to different projects, you will thank yourself. It can be quite tough to work everything out after that. So if I want to access Azure Cosmos, I need to use the keys down the bottom. Just go there. And what I need is the URI, which is there. And then I can use either a primary or a secondary key, or I can use a connection string. Right, so let's have a quick look at the data that I've got in here. And that's up and running. Deployment succeeded. So this is the one that I created just a minute ago, which is the Pass Hybrid VG. So it doesn't have any data in it. So we can start to add some. So we've got the Data Explorer here in the left-hand side. So what we've got here is got just one database in there. So I'm going to set up another one. And I'm going to call it Jen Stirrup because that's me. Provision throughout. So I can add in throughput there and click OK. It's going to have to think about it. So we see here I've got just Jen Stirrup, but I need to add in a collection as well. So I'm going to call it a collection and we can call it Volcano. So collection ID, and that's the ID for the actual identifier for the item. So I believe that's called ID. Then we could add in a partition key here. So we can see here they've given us little help tips along the way. And then we can start to click OK. And then that would allow us to start to upload our data here. So if we go back to home, we can look at the one that we did earlier. Data Explorer here. And I've got a few different folders of data which I uploaded earlier. If you want to upload data, you can upload JSON documents here, and that leads you to a file explorer. And that would start to take us exactly where I needed to be. I can start to get some data and upload that. So I could upload this Volcano JSON file if I wanted. The other thing that we could do is there is an Azure Cosmos migration tool. And we'll see if we can find that. So Azure Cosmos upload data tool. So there is a few ones. There's actually an Azure Document DB upload tool, and actually you might find that first when you do an internet search for it, but the one you're actually looking for is the one in 2018. So just be mindful of the version that you're looking at. So what we've got here, obviously got lots of different ways that you can structure the data, and there's a tool that you can go and get the data tool from. So that's available in GitHub. And you can find the repository just here. So I can leave that with you to go and have a look at. You can also upload data in all sorts of other ways as well. You could use SSIS or something like that. But all we're doing here is just a quick example to show how Azure Cosmos actually works. So you can start to see here lots of keys. Now first that can look a bit confusing. Now what we've got here is the database name. It's called items. And then we've got a collection. A collection is simply a collection of documents. And they're both called items in this case, but you'll know which one is the database because it has this really swish planet logo, which I think is really cute. So how do we actually see the information here? So now if you click on the ID, when we click on each one, then we can start to see, right, so I've got my data just here. And I can have a look at it. Now, since we are in business intelligence, we look at this and we think, right, that's great, we've got the data, but how can I really present that to make sure that customers and users can read it really well? And this is where Power BI starts to come in. So let's set up Power BI so that it can actually connect straight to this Cosmos and it will get the same information as well. So I'm going to stack up Power BI. Power BI desktop, here we are. Here we go. So I've set one up already, and I will show you how we connect to the data. So what I want to do is I want to get data. And I want to get the data from Azure Cosmos. So to do that, I'm going to do get data, which is up here. And then I'm going to choose the more option, which is right down the bottom, just here. So get data, then more. And this time we see we have got a lot of options. And the one that we are most interested in is Azure Cosmos DB. And that's in the beta format. But that's the one we're going to choose. We click that there, and we're going to connect. So the URL is going to be the one which we have here in the Azure Cosmos interface. And what I'm going to do as well is I'm going to copy the key because we will need that. So the database that we're going to choose is going to be called items, and the collection is going to be called items, and that matches to what we have in our Data Explorer. Items just here, items and items. When I look at it now, I could have given it better names, but that will do for now. So what we see here is it looks a little bit odd. We have the heading document, and that's because it's the data storage format. And then we've got record. And the record is actually referring to the actual individual document. So we're going to load that. So access to the course resources forbidden. It says, so I'm going to add in a different account key and see if that works. Alright, didn't expect that. So I'm going to take this one this time. I don't suppose it makes much difference, but let's have a look. Right. It says the credentials aren't invalid, but let's go and try. Here's one I did earlier. So edit queries. So both of these queries here actually come from Azure Cosmos. That's really strange. Let's have a look. Okay, so anyway, here's the data that we actually see coming in from the Azure Cosmos. So we see here the volcano name, and I'm going to look for Rainier. So we see we've got Rainier just there. So this actually matches the information that's stored in Azure Cosmos, and we can show that. So we've got stratovolcano, for example. The elevation is the elevation, the size, basically that is height. So I'm going to undo the filter. I'm going to select all and click OK. And when we look back in Azure Cosmos and we look back at our data, we can actually see when we click in Documents, Rainier is the first one. Actually, it's not the first one. You can find it in here. We could look for Alutu instead, so let's do that. So when I go back to the source, volcano name, we can search for Alutu. There. So that's in Ethiopia, and the status is Holocene, and it's undated. And that's the elevation. And when we then start to look at Data Explorer, we can see the same information here. The elevation is 2335, it's a stratovolcano, and it's a Holocene. So the point I'm trying to make here is that Power BI and Azure Cosmos, we've got the exact same data here. So now we've got this in Power BI, we can start to visualize it and try and make it look a bit more interesting. So to do that, I'm starting with a new canvas here. Now the queries that we've got here are not very well named. We've got query 1 and query 2, so we could change those. So I'm going to rename that query, and we'll rename it to volcanoes. So now we've got a lot of information just here about the volcanoes themselves. So as a starting point, let's add in the volcano name. So we can see here we've got quite a lot of volcanoes. Now normally when we visualize data, we try and make things as easy for people as possible. So we can add in volcano count as well. So what we can start to see here is that most of them we have volcanoes twice, and then we've got this one which appears 4 times. So that would be interesting for us to start to look at. But what we could do is actually set up quite a nice map. So first of all, what we can do is set up the country, and that will help us to see exactly where the volcanoes are based. So what we see here is, just as a summarise, we're getting our data from Azure Cosmos DB, and we are visualizing it in Power BI. It's really super quick. I'm just using basically home Wi-Fi, and even though I'm just using home Wi-Fi, it's really nice and quick. And what we could do then is start to play around with this a bit more and do something nice with it. So we've just got the volcano names here. Now people tend to like tooltips. I'm going to add in volcano count here, and we'll add in the count, for example, to the size. And then we can see if really more volcanoes are actually included. Now the reason this comes up with a double count actually is because when we look at the data for each of these, they appear twice. Volcano name. The reason for that is the coordinates here. So we've got the coordinates, we've got the X and Y axis appearing as a column rather than in a row. So what we could do is we could start to play around with that and split it out. And we won't do that here, but that's something we could consider. We could try and retrieve the data in more easily as well and start to filter out duplicates, but for the moment that will be fine. So then we start to see our data here. So what we can do is perhaps filter it by the type. Now one thing I like to do when I'm visualizing data is I try to put a question up here. And the reason I do that is because sometimes when I'm looking at people's reports, their database, the data actually doesn't match the business question that they're asking. So if you've got something like, tell me about volcanoes of the world, then that really means they've been very specific about what I'm looking for. So I'll put that up here, so it looks better. I could put in a logo or something over here, but that will be fine just now. So we can start to filter out as well. And to do a filter, I can use this slicer over here in the right hand side. So I'm going to choose that one. So I put that back to map. I'm just going to add in a filter here. Now this filter doesn't have anything in it because I've not chosen a type, but what I could do is choose a type here. That will allow us to identify what the volcano actually looks like. So we can see here there's a bit of tidying up that could be done on the data. So for example, we've got cinder cone and cinder cones. We could amalgamate those together. So there would be less options. They pretty much mean the same thing. So we could do that. We've also got cone here. I'd be interested to know, is that a cinder cone or is it a different type? But then we've got lava cone here. So for me personally, I'd be interested in trying to make that clearer for the business users. But that allows us to actually work out and filter some of these. So say I'm just interested in lava domes. This shows me which part of the world the lava domes actually reside in. You'd also do different types of sources here. So that's just a filter. You could add in an extra filter, and that could be a different type of database. So here we've just got points, just as one example. Now I personally don't really like single select, so I'm going to click back in that, and I'm going to go to the paintbrush option here and see how I can start to change things so it's clearer. So I've got selection controls at the bottom, and I'm going to add in the select all option, and then I'm going to change that so I no longer just have the single select option. So when I do select all, obviously my volcanoes come back, but I've also got an additional option in the type 1 filter as well. So that's just a few different things that we can do with Azure Cosmos. What we could do, just as our last few points, we can export that as a Power BI template. We could also export to PDF. We could publish to Power BI in the cloud, so let's do that. Save the changes. And I'm going to change that so it goes to, just put in to ad hoc consultancy, that will do. In fact, I'll do it to my workspace, so I don't have any customer data in there. So that's publishing it to Power BI on the cloud. So what we're doing is we're taking the data from Azure Cosmos DB, displaying it in Power BI on the desktop, and then we are going to see how that data looks in Power BI. So you can see how quick that was. I'm just going to click this link here, which is Open Pass Hybrid Webinar, which is the name of my Power BI workbook. And then I just need to sign in. So we can start to see here. And that's just an old example I've got. My workspace. I've got lots of examples here. Then, gosh, I have been busy, haven't I? Wow. So there I've got the data set for the Pass Hybrid webinar. Then I can start to add in, that would just say connect to the Azure Cosmos DB, and it will display the data that way. But if I wanted to see the actual data thing that I created, we can see here that this will give us a Power BI workbook. So that's us in the cloud. I'm actually using Firefox in order to display my data. But you can see here it still works, so all the filtering will still work as well. So there we go. So I'll just do a quick recap and a quick summary of where we got to. So we had a look at Azure Cosmos DB. It's very easy to upload data to it. We can use the Cosmos DB file import tool, or we can upload directly using that. Or there are other functionality we could use in order to do that automatically, such as SSIS. We then get our data in Azure Cosmos, and then we can start to visualize it in Power BI. So I just want to give kudos and credit mainly to Microsoft. They set up an example using the volcano data, and that's the data that I used here. So all credit to them for that. You can go and download it yourself from GitHub. And the nice thing about that is you've got all the notes, all the sample data, so there's no excuse to yourself not to go and get started. And that really was the end of the show for this evening. So I'm just going to double check to see if I've got any questions, because I've ignored that up until this point in time. So if anyone has any questions, please feel free to reach out to me at any point. I think Azure Cosmos is lots of fun, and it's very easy to get the data back out of it again. So I hope you enjoy using Azure Cosmos. So with that, I think we are looking at wrapping up the session. And I'll hand back to Mark to see if there's any comments or questions that we might have.
I actually have a few questions for you. So one of the things that worries me a little bit about unstructured and semi-structured data sources is that is there a danger that when you're doing queries that if somebody's inserted a record which uses a slightly different key, that you're going to miss data when you query? So an example is if someone, for instance, uses a first name for a tag and somebody else uses, I don't know, forename, for instance.
Yes, I think that is one of the dangers. I think that's why I think data preparation is so important, and I could wax lyrical about data prep all day. I think that's a very valid concern, and it's something that I do think some software actually tries to tackle that. So with something like Microsoft's, I think the Data Factory, I've forgotten the name for it, isn't that terrible? Is trying to address that issue, but they are, so Microsoft Data Preparation, I'll see if I can find it actually, because that's something I think that they are tackling. And they've got Microsoft Data Flow, and that's something else to think about as well, to try and tackle that issue. So there are other third-party tools that help you to sort of visualize the data when it's in a big data format. So some of those include people like Trifactor, Pixata, Datamere, and these third-party tools, what they do is they visualize unstructured, semi-structured big data sources, and it's like a query filtering mechanism, a bit like Microsoft's Power Query, and then things jump out there. But I think the issue is in traditional data warehousing systems, as you know, Mark, I know you know this, but this is just my take on it for people tuning in. In traditional data warehouses, we always focused on time to answer. So how quick is it till the person at the end gets the result? And the reason that happened was because we managed to do ETL processes that meant that we absorbed the pain of cleaning up the data, tidying it, structuring it, and putting it nicely in our data warehouse. But I think with the big data systems, you're pushing some of that pain onto the users. So it then becomes a question not of time to answer, but more a question of time to question. How long does it take to get the information that they need? Then how long does it take to get them to ask the next question they're going to have after that? And I think it's a really valid concern. The solution that I see, I would like to see, and I believe my guess is Microsoft will be on this path, is data preparation tool that uses machine learning technology to try and work out if something has got the wrong information in it. I don't think it would be easy, but it would be almost like using AI to do BI. I think in some ways the technology is still very young. I don't know if you think this, Mark, but I do think the problem of missing and problem data is something the industry really hasn't really got to grips with. I don't know what your thoughts are, really.
Yeah, I think there's definitely some data quality issues and maybe things that we should consider implementing, and not, but then you could argue you're making semi-structured sources more hassle again, so I don't know.
Yeah, it does push it to the end user, but I don't know about you, but my experience, if you say to a business user, right, you need to sort out your process, and you know what, you're going to have to be more careful putting your data in. It's like you've asked them for the absolute earth. What do you mean I need to change my process? And I don't know if I can think of a few places where I've seen this, where the front-end GUI has like virtually no correction in it at all.
Yeah.
And you think, oh my goodness, so people are just ramming in all sorts of data all over the place. One of my organisations I was working with, they incentivised their staff to enter data, because they said, look, we're missing data all over the place, and if you enter lots of information in and reach a certain target, you get some sort of incentive. I've forgotten exactly what it was. But what happened was people filled in data all right, but then I ended up with systems with email addresses like a+a@b.com, and people were solving the problem of missing data by entering rubbish data. And then you just shifted the problem along. You weren't actually dealing with it, and it was just morphing into something else. And that's because it's humans. We don't like doing what we're told. And I must admit, I'm awful at doing what I'm told. I never really learned that lesson in life. And asking people to say, you know what, they need to do some data cleaning at your end is really difficult. I could talk about this all night. It's one of my pet peeves. Sometimes I think I just don't like people very much because I just want them all to have tidy, clean data.
Okay. Well, maybe if somebody needs that problem solving, Data Relish can come to the rescue. Right, so...
Well, I don't know. I've actually turned down projects like that because it's been so bad. I've walked away.
All right then. Well, they can come to me and I'll make it up as I go.
I will pass them to you. You can smack them over the head.
Next question. So, is there any good way of predicting the cost of Cosmos DB? I mean, I guess you could obviously watch your resource cost usage in Azure, but is there any better ways than doing that?
This is something I've started to look at. Now, this is not specific to Azure Cosmos, but one of my customers just came to me and they said, Jennifer, we cannot understand our Azure bill. And I thought, well, how hard can it be? And then they showed me and they said, we can't track back what is in a subscription, and that relates to different projects. So we can't estimate the cost of our projects very well because we don't know what artifacts belong to which project. And I suddenly realised actually the tagging functionality that you've got here is a good start. But I think people get very confused by it. So I think, so you've asked a really good question because I very rarely think about the cost of Azure, and I should look at it better. I just try and work out, get the customer really to think about it. But they've got this, Microsoft bought this great software called Cloud-In. You can get this through Microsoft Azure. I think you have to sign up for it specifically, but it is an Azure cost management.
Oh, cool.
And it's free to customers and partners managing Azure. And so I actually recommended that my customers started to look at this just as a way of understanding it. And the real key to it was actually, as I have completely not done here, tagged. They're just tagging things. But no, I totally agree. I think they get confused over the billing. Let's see what my bill is actually. I've got nothing to hide. Here we go. Billing account. So we can see here the scope. Maybe we can add, oh yeah, here we are. For more cost management and optimizing capabilities, use this. And that takes us into Cloud-In.
Oh, right.
So, all right. So, yeah, that's cool. Isn't it? That's
fairly
cool.
new then, is it? Because I've not seen this before.
Yes.
Okay.
Yeah, I didn't realise it was as cool as it is. Yeah, I only saw it recently, and it was only because a customer asked me about it, and I must admit, I'm still finding out about it. And it was only because the customer said, look, you know, I really don't understand this, and I had to go and look at it. So to sort of answer your question, advisor recommendations, I think this is a cool feature. I think Microsoft are getting a lot better at this, where they are helping you to estimate costs. And I think they also get better, or will get better eventually, and trying to work out if you could optimize your service in some way. I have seen this with Azure Virtual Machines, where it does like a little check that says, you know, you could really tidy up your security by following these steps, and it's like a little advisor. Now, I'm not going to pretend I'm the most technical person in the world, so I do like these wizards. They do give me help in understanding what's going on, because I'm busy, and I actually find Azure moves so fast. I find it really hard to keep up sometimes, and this is why, for me, I like doing these webinars, because I have to really go and look at it and try and understand it. So it's got some recommendations here. Security. Uh-oh. What do I need to do for security? So see a list of cost recommendations. So I think it must go and use some AI and start crawling around your estate to see what's happening. But no, you've asked a great question. I wish I knew more about it. It's one of the many, many things I'd like to do if I had some more time. But I think this is a great functionality. And this is, you're right, it's brand new. I've not seen it or used it, which is why it's not set up.
Yeah, no, I'm going to have a play with that. That's good. Right, so as I understand it, and I think you've alluded to this already, Data Explorer is going to become the primary management tool of Cosmos DB.
Yes.
But are there actually any client-side management tools that we could use, you know, similar to SSMS or, I don't know, something like that?
Well, it's a great question. The only one I've really seen come across is the tool for uploading data in Storage Explorer. I think they're just pushing everything into the cloud as far as I can see, just getting everyone to use the portal. I think that might be a nice idea just to have something that people can manage better. Do you know what I really love is I'd love to have like an add-in in my browser where I could just almost like have all my resources wherever they are. Say I go here in my dashboard. I just want to be able to sort of click over an icon and see that everything is running.
Yeah.
I just want something super simple like that. I'm a simple person. That's how I see it working. So I don't know if that helps any. There's so many great things with Azure that they're doing, and it makes it interesting. I found some other new functionality as well. I've been sort of playing around with it. So Azure Migrate is a new thing that's just starting to come out as well.
And so you use that to migrate data as well, would you, to Cosmos?
I'll use it to migrate it even up to Azure generally, and then you get to choose. Oh, what's that got to? Oh, sorry. Yeah, I'll create a new resource. So Azure Migrate does this cool thing. It allows you to discover and assess your estate. Say you've got a bunch of on-premise virtual machines, and then helps you to put your data up to the cloud. So I think this is quite an interesting thing as well. So it's really does this really interesting discovery phase for virtual machines. And then you've got to think about what's the Azure readiness like? Is it suitable for running in Azure? But when customers come to me and they say, I want to talk virtual machines, I'm interested in whether they actually want to move the virtual machine or do they want to move the actual data itself? What do they need to do? So I think this is quite new, and I thought I'd point it out because I was interested in the fact it does this discovery phase, and then it gives you a really nice assessment report, which kind of looks something, I guess, like this. And once you've got your assessment in play, you can then think, right, how am I going to group up these Azure VMs and get, or how am I going to group up these VMs and put these up into Azure. So there's a lot of really nice things. I love the fact they are doing so much visualization in the portal. I think that just makes it simple for me. I'm a simple person. I need things fast. I don't want to think about it. Give me pictures. So it works so well for me.
Okay, excellent. So moving on to Power BI. I know there's a lot of confusion really about how and when you can use Power BI tool. I mean, what I'm really alluding to is what are the licensing restrictions of using the tool? What do you need in order to install and use Power BI desktop?
Yeah, so you can use the Power BI desktop versus the online version, which I think I had open somewhere. So with the licensing, I tend to refer people to the website for that. I'll be honest, I cannot ever remember licensing, and the reason for that is when a customer asks me about licensing, a bit of my soul dies because it moves so fast I can't keep up. And I wish I could. I really, really wish I could keep up better with it. So what I tend to do is I don't sell Power BI, if that makes sense. I always send the customer back to Microsoft and to look at the licensing. The reason for that is I'm not a lawyer and sometimes worry that I'm going to get caught in conversations and it'll be Jennifer said, Jennifer advised, and that's not the case. So I do know that Power BI Premium is where you get dedicated Azure artifacts that support Power BI. With Power BI Desktop as well, you can do more in the desktop at the minute than you can in the browser, but what I do notice is that the browser is not that far behind and it's catching up. So I think eventually the gameplay will be that you'll be able to do stuff in the browser and in the desktop. Some of my customers will not put anything in the cloud, and that's up to them. You know, they have got various reasons for that.
From that link that you showed, it looks like to me like if you're authoring your own stuff, then it's fine, it's free. But if you want to share and collaborate with other people, that looks like the time that you then need to start paying.
Yes, I think that's a fair assessment, and that's how I've understood it as well. And one of my customers does exactly that, actually. Sorry, my computer's crashed, or it's frozen, one or the other. So I think that's exactly right. And one of my customers does that. Their data they regard extremely sensitive, and they asked to see copies of my data protection policies and things before I went on site, which I furnished them, and they just use this. But I think the real key to collaboration is that you do share data, and people do want to share the insights, and that's when you have to start to think about how do I move it to the cloud, or do I use Power BI server and use that in my estate. But of course all of that is a bit paying for something, and I do so when I hear customers say, oh, I don't want to pay for that, I do think, well, Microsoft are not a charity, and there has to be some sort of quid pro quo at some point where you think, you know what, you've given me this software, but to do this other stuff, you've got to pay because it is a service they're using. So I'm a bit funny about that. I know that's not a very popular point of view, but I think it's right that they do charge and they do have these licensing abilities because they must have invested billions in Azure, you know, and it's, to then give it away all for free is a bit odd. You know, they have to, it's quid pro quo like anything else. That's just my take on it.
Okay, cool. So we've got a message from Kenneth Van Orden. He says, when
Hello,
you
Kenneth.
database is hosted in multiple regions, do you need to specify different connection strings within your application, correlating where each user is versus your DB region? Or will the URL you copied handle directing your user to the correct region in the Azure networking layer instead of the developer's application layer? So, well, I don't know if you understood that, but I'm guessing he's referring to the geo-replication potentially if you get failover. Yeah,
I think that's right. So you can distribute the data globally with Azure Cosmos DB. So I think I obviously didn't set it up in order to do that, but the connection strings, all they do is let's see if we've got a connection string. Just here. Home, then here. Keys. I believe it just asks you for the account and the database name. So I'm just going to copy that just so we can see it better. I'm going to start up a notepad just so we can see it.
While you're looking at that as well, Kenneth's also made a point about Storage Explorer starting to gain functionality for browsing data. I've certainly used it for playing with blobs, not necessarily playing with looking at Cosmos data, so I'll take a look at that one.
Oh yeah, that sounds nice. Thanks, Kenneth. So I see the account is actually being here, so it's not actually pointing to anything geographic. All it's doing is asking you for the URL. So there'll be the Azure load balancer behind there somewhere, because Azure Cosmos is all managed for you. I imagine there will be some sort of load balancer. It's level 4 almost of the OSI model, sort of transferring the data around the place, and that's going to give you, that's just going to point you to whichever region is closest to you probably, and whichever one's going to be fastest. And then you've got this, quite frankly, awful account key, which we can see here, and it's supposed to be awful. I'll be deleting this, so if anyone tries to access it, tough. And then we've got the database name, and that's the connectivity, so there's nothing geographical here at all. I'm guessing the actual key to Kenneth's question is actually here. Because you do get Azure Load Balancer, which you can set up in its own right, and it will direct web traffic to wherever it needs to go. So my guess is, I would have to look it up or ask, or maybe they won't tell us because it's proprietary, that there'll be something behind the scenes which will be directing you towards the correct place. But certainly I can take that question offline. It's an interesting question, and thank you for asking, Kenneth. I don't have a definitive answer, but my guess is it's the account key, and it's actually the endpoint that you're looking at. The endpoints can be then used with the load balancers and things behind it. I wonder if that's like just a normal standard Azure endpoint that you'd set up anyway.
Yeah, possibly. It's definitely one for a blog post, isn't it, sometime?
In another lifetime,
yes,
maybe. But I can try and find out.
Yeah. Right, so final question. I was quite interested when you did publish of your Power BI workbook to the cloud, and I wondered whether the source data was cached up to your cloud area. So,
yes,
so in other words, the original data source wouldn't have to exist anymore. Is that how it's working, or is it referencing the original source?
So I believe that the data is transferred onto Azure Blob Storage.
Oh, right.
Which underpins what Power BI does. I do have a presentation on the data storage behind Power BI. So I don't know, it's a good question whether it goes straight back to Azure. Cosmos does a call every single time. It's a great question I want to ask. But a good place to sort of understand more about that is actually Power BI security. There's a white paper about this.
Okay.
Yeah, this is... I really recommend a read of this, and there's quite a few of them, but the Power BI security one has really helped me in a lot of projects because people ask a lot really about what happens to the data. Lob. There we go. So Azure Power BI uses Active Directory, Azure Active Directory to store manage user identities and manages storage of data and metadata using Azure Blob and Azure SQL Database. So my guess is that the data is coming from Azure Cosmos, but any images and say logos, anything like that, and report metadata gets stored in Azure Blob. I would need to double check whether it's extracting straight from Azure Cosmos or whether it's going into Blob storage first and then going into Power BI. I suspect it's actually coming straight from Azure Cosmos because it is so fast. It may actually add in some latency to go via Blob storage.
Yeah,
But this is a real interesting.
My concern though is GDPR. If you're querying sensitive data and publish a report on it, and then you've made a copy of that data, so that's maybe something to think about.
Yeah, the thing with GDPR and processing the data is what I do say to my customers is if you have any doubt, if you can share that data, don't share it. Yeah. So in a project I did last year, what we did was we did like an agile approach. So they kept saying, we're not sure about these 2 columns, and I said, well, let's put the rest of them up. We can't kill the project just because of 2 columns of data. Why don't we put the other 84 up? And the others are not a no, they're a not yet until your lawyers have looked at it. So I think the lawyers are still looking at it, but in the meantime I've got a happy customer who's happy with the data they've got in the cloud and they've got in Azure. They're not missing those 2 columns actually, so maybe that's why it's been downgraded. But if customers are not sure, I suggest all they do is do that staggered approach, put what you are confident about in the cloud and the rest of it. If you're not sure, then don't.
Cool. And read the white paper, of course.
Yes, or I will hit them on the head with it.
Yes. Right, so Paul Bunting, awesome stuff. He's basically put a couple of comments. For control of endpoints, it is done through connection policy class in connection APIs, and he's also followed up with a rather long URL, which I'm not going to read out, but I'll read the words so you can do a Google for yourself. It's on Microsoft Docs. How to manage database account configured clients for multi-homing. So you might want to look that up sometime, people, if you're interested in that sort of stuff. So I believe, Jen, that's all the questions, and that's everything from me. So I just want to say thank you very, very much for coming on and presenting. Really enjoyed it. I think I'm going to be trying out your stuff tomorrow. Hopefully you might even get a few messages from me tomorrow to say help. So you might want to hide when I do that.
No, not at all. I'll probably get a few messages to say, Jennifer, you were utterly wrong. And that's fine too, because I will always learn something.
We'll see. I'll do my best, but you know, I'm hopeful I'll make progress. No, it was really good. Really enjoyed it and learnt loads of stuff. So I hope to get you back in sometime.
Oh, thank you. I'd be more than happy to do that. And yeah, it's been really great to speak to you. And one reason I do these sort of webinars and user groups and things is so I get to see people like you, Mark, that I don't see often enough. So it just means I can actually pin people down and spend some time and chat with them. So it's been really great to speak with you as always. Thank you for your time. It's been good.
No problem. Thank you everyone for joining.